Welcome everyone to today's session, Advanced Data Science for the Audit Professional. Before we start the session, I just would like to ask you if you have any questions for me, please use the chat, write them down, and I will try to answer them at the end of the session, or maybe I can send you an email later on and provide the answers to everyone. So please feel free. We'll wait another couple of minutes to see if there are other people joining us, but please, in the meantime, if you have any questions for myself in relation to data science, data analytics, anything to do with these two in audit, please do put them in the chat box. And of course, please feel free to do it during the session. So once again, great to have you here. We'll wait another couple of minutes and we'll kick off shortly. All right, well, let's start. Welcome to the new people. I also have here with me my colleague, Amira Kadaj. So if you have any questions, please, you can send them to Amira, or you can send them in the chat box, and I'll try to answer them towards the end of the session. So today, we will be talking about data science in audit. Just a little bit of background about myself. I have been involved with data analytics and data science in audit since 1994. My first job was building a continuous auditing system for one of the large corporations here in Australia. And this is where my career started. So all my career has been spent in digital risk and also data analytics linked to audit and fraud. I'm based in Australia, and I know that today a big part of our audience is Malaysian. Before COVID, I have been to Malaysia 17 times between 2017 and 2019, running various types of data analytics and big data training courses. So welcome again, everyone, and let's start with the session. A little bit of a definition first. So what exactly is data science? Because if you do a search on Google, or if you speak to your colleagues, there'll be a lot of different definitions, a lot of different opinions. So just to keep things simple, data science uses scientific methods and processes and algorithms to extract knowledge and insight from noisy, structured, and unstructured data. This is the really important point. Before, like 5 or 10 years ago, we had the privilege or the luck to deal mainly with data which was clean and structured and easy to understand. That's not the case anymore. We are now having a totally different situation where there is different data types, and we'll talk about that shortly, and we need to be able to process them. And this is what data science allows us to do. Data science is related to a number of other disciplines that you might have heard, like machine learning, big data, data mining. All of these are linked with data science. They quite often overlap. Quite often they also need to work together, so they are not mutually exclusive. But this is just a quick definition of data science. More on the technical side, but the one that personally I think is really important when we talk about data science is to look at the purpose of data science. And here you see a photo of Peter Drucker. This is one of the top management consultants of the 20th century. He was born in Austria, later migrated to the United States, but he is one of the, as I said, the people which are considered the top. And what he says in one of his books in relation to the management challenges of 21st century and specifically digital technology, his view is that the purpose of information is not knowledge. The purpose of information is being able to take the right action. And this is extremely important when we talk about data science and data analytics in audit. Because very often we focus on the tools, we focus on the process, but we miss the purpose altogether. So when we do some sort of data analysis and data processing, the ultimate goal for it is to be able to present something to management, to the business, to a number, to external parties maybe, and some they will be able to do something with that information. So when we finish an audit and we use data science within that audit or data analytics, and we present our findings, we want whatever we've uncovered using various data processing methods, people to do something with it. It can be the accounts payable manager who will improve their processes. It can be the maintenance manager who will know what they need to do, that they need more people or which areas they need to pay attention to. Maybe it's the HR director who realizes what are the deficiencies in terms of training for the employees, and they will do something with it. So all of these things are being able to take the right action. So we don't want just to know things. We are not at work to learn things and to know things. This is what we have done at university and at school. We actually need to do something with the information that is at our fingertips. Really important. Please do keep that in mind, because quite often people just get sidetracked and then various data analytics and data science initiatives do fail. Now, so continuing from that, data science is about business outcomes. This is the most important thing. We analyze data in order to achieve some sort of a business outcome. This is definitely not a technical initiative. All right. Quite often people think, oh, well, this is something that the IT department need to do because there is the word data in somewhere there. No, this is a business initiative. This is an audit initiative. Yes, you can get help from the technical people, no question about that, but it is the business or audit in this case that needs to be driving that, not the technical people. So it is not specifically data mining, data science, big data, statistics, etc., etc. It can be, but it is usually a collection of these that we are using to achieve a specific business outcome, going back to number one again. The other thing is that it can be either very complex or very simple. People just hear sometimes the term data science or data analytics and they think, oh, wow, this is so difficult, I won't be able to do it, this is not for me, there needs to be somebody in audit who specifically is involved with that. That's definitely not the case. There are simple things that can be done by pretty much everyone, and there are also complex things that, yes, definitely only some of the people on the team will be able to do. Which brings me to this point here. It is an activity that 50 to 80% of the auditors can do. We just don't know that. People just get scared. 50 to 80% of the people on the audit team can do. It's not that complex. In its simplest form, it is if you can do a search or a sort in Excel, you will be able to actually use data science and data analytics in your audit work. So don't be scared by the big words and the big names. It is something that a lot of people can do. And this is what here, this is my personal view that before starting MBS Academy, I have worked as an auditor, as I said, for 20-something years. My personal view, and I've been an auditor, I have managed audit teams, I've seen various situations in large organizations, in small organizations. I'm fully convinced that most of the people in an audit team can do some simple data science. The complex things will be left, of course, for a handful of people. But if most of the people, like 80% of the auditors, start incorporating small elements of data science, the productivity of the team will go through the roof. So let's talk about some of the benefits of data science. All right. So the first one is increased reliability of findings. Okay, I want you to imagine this situation. You are doing an audit of accounts payable, okay? And you want to have a look at the payments. All right, so you have one big pile of payments, let's say 500,000 invoices. This is not that much. I've worked in organizations where this is towards the lower range of the number of invoices processed per year in the organizations that I've worked with. So you have 500,000 invoices, all right? And you need to be able to write in your audit report and draw some conclusion and provide an opinion. How is the payment process within the accounts payable going, all right? Now, I'll give you something else. According to various sources, about how 0.5 to 0.1% of all payments in an organization are duplicates, all right? So now, if we take back the 500,000, which is low figure anyway, that means that in the specific organization, there is 250 to 500 duplicate payments per year, all right? Now, we don't know how big those payments are. They can be for 1,000 ringgit, they can be for 100,000 ringgit. Difficult to say until we've seen them. Okay, so now my question is to you in the audience. Think about it this way. How comfortable would you be if you just do some sampling of the payments in the associated invoices and provide an opinion that the payment process within the organization is okay? Okay, there are no issues and no findings. How comfortable would you be? Personally, I will not be very comfortable. However, if I'm using data science and data analytics and I run the audit tests across the whole population of records, on top of the 500,000 invoices, and I see what are the exceptions and I see what are the duplicate payments, I then will know very well how good the process is. And whatever I write in my report, I will be able to defend it because I've got some hard figures to support my conclusion. Because quite often, I've been in a situation, if I provide an opinion in an audit report, which is not very good, people start pushing back to me. How do you know that? We think that it's good. Yeah, okay. Well, if I have the figures here, and I can show them, yes, we have analyzed everything. We took the population for the last 12 months. We've run the audit tests. These are the exceptions. Now, this is what my opinion is based on. Difficult for anybody to say anything against that. But if I tell them, well, we have sampled 20 invoices or 20 pay dockets out of 500,000, they'll just laugh at us. So number one benefit of using data in audit work is the increased reliability of findings. Number two, very important, is reduced time and consequently cost. Now, how long would it take you to sample, let's say, 50 payments from the pile of payments? You need to find the sample, you need to decide, you randomly can sample them, and then you need to investigate them manually and see what's going on. That will take time, as opposed to running some analytical tests, by the way, on 500,000 invoices using the contemporary technology. A test like that would probably take 3 seconds, and then it will take probably another 30 minutes to set it up and to have a look at the results. So we're actually making the people on the audit team much more productive. We are reducing the time that an audit review will take, while at the same time we're increasing the reliability of the findings. So if we manage to shave 2% out of every, in terms of time, out of every audit review, then during the year we'll be able to perform one additional audit review for every 50 reviews that we've done without any increase in the budget. So actually, we are saving money as well. Now, the other thing is that when we look at the whole population and we have the full picture in front of us, now we can get new insights. Now, if we go, let's say, if we start analyzing, we are doing an audit of the maintenance function in the organization, and we start analyzing the data, we can see who are the best maintenance engineers. What is the equipment that actually requires more frequent maintenance than the norm, than the one recommended by the manufacturer? We can then start looking at the reasons behind all of these things and provide some business advice, not just purely audit compliance type work, but we can be seen as consultants, as audit consultants, not just auditors. And this is one of the things that organizations like the Institute of Internal Auditors recommend, that auditors start thinking along those lines. So data analytics, data science gives us that opportunity to start becoming consultants, because we will have the insights. Now, some specifics in relation to risk and audit. Now, data science is part of the standard audit reviews. So, as I said, it needs to be linked to the business. And as I said earlier, it is not something that we do on the side. It's actually incorporated within each one of the audit reviews. And when we run our training courses, actually, I teach a specific process how to go about it, because we actually want to see audit analytics used within the audit reviews. It is not just software. Again, I'll repeat, because sometimes when people approach me to run courses, they say, we're using ACL or using IDEA or we're using Excel or whatever. Yet, this is part of the whole picture, but definitely not the whole thing. So there is a number of tools out there. Various organizations have their preferences for one reason or another, but it's not just software. There are other things. So there's a whole process of getting the data, deciding what to analyze, what not to analyze, what is available, because sometimes not everything that we want to analyze we can, for whatever reason. What are the data sets? What do they look like? Who is going to provide them to us? And then it comes to the tools. Can be IDEA, can be Excel, can be Access, can be ACL, can be 9. And at the end of the session, you will see a demo of a fraud detection system built using 9. So all of these things come together. Just based on my personal experience in doing audit analytics over so many years, one of the biggest challenges always is access to the data, getting the data sets. The actual analytics probably for my teams and for me personally would take about 30% of the time. Getting access to the data would take 60 to 70% of the time. So just keep that in mind when you start progressing with some analytics initiatives. This is basically based on my personal experience. Now, doesn't affect the audit objectives or scope. Whatever the objectives are and whatever the scope of the audit is, stays the same. It just makes the actual audit engagement much quicker, much more credible, much more efficient. Now, what are the suitable processes for data science? Well, it is about data. So they need to be highly automated and they need to be data rich, which for medium to large organizations these days is pretty much all of the processes inside. Some examples, some obvious examples, payroll, lots of data. Purchasing, again, the same thing. Maintenance for organizations that are dealing with various types of equipment. Can be construction companies, can be travel companies, can be airlines. Sales, something which is present in pretty much any organization, unless it's a government organization. Again, all of these processes contain a lot of data that we can start using to make our lives as auditors easier and to provide more value to the organization. And if you go through an organization and if you start looking at what's available, I'm pretty sure that you can discover a lot of other candidates. One thing that I would suggest to everyone, when you start an audit, unless you're already doing it, just think, is there any data sets that we can actually analyze to achieve some of the audit objectives within the scope of the audit? For me personally, that's basically a second nature. Anytime I used to do an audit, I'm mainly focused now on teaching, but anytime I'm doing an audit, I will think the first thing, okay, what data is available so that we can actually see what data science we can do here. Now, some of the requirements that we need to keep in mind, these are not set in stone, but they will make life a lot easier for everyone. First one is to have a central audit repository. So basically, a database doesn't need to be maintained by audit. Usually it isn't. It can be just maintained by the IT infrastructure team, but some place where the audit data is stored, because then audit can access that data whenever it's needed. There is no need to ask for data every time. That solves that problem. And also audit can perform reviews and investigations without actually alerting anybody. I was in a situation like that about 10 years ago when there was an investigation that had to be done. And the person running it came to me and said, Mario, here's a contact number of somebody in IT. Please do not talk to anybody else except her, because she's the only one that I trust not to let this whole thing out of the bag and let everybody know that we're doing something, because we need to finish the investigation before we announce. It was a fraud investigation, so we have to be very careful. If there is a central audit repository, this is not an issue. All of the data is stored there for audit to use. Now, the other thing is transfer automation. Once we have the repository, the ideal scenario is to transfer the data automatically to audit. This is not that hard. Most continuous auditing systems, and I'll touch briefly on that a little bit later, do it. So every week or every month, doesn't need to be real time. Usually for audit purposes, that's not necessary. But on some specified period, weekly is usually okay, can be monthly sometimes. Transfer the data sets to audit, and then they're available to audit to use for any review that they're running in the future. And then also, we want these things to allow us to perform complex tasks, much more complex than what we're used to. I'll give you an example, going back to accounts payable. For those of you who have studied accounting in university, you probably have heard of the three-way match, one of the basic accounting controls, where the purchase order needs to match the invoice and needs to match the delivery document. Okay. Now, not very easy to do that type of work in Excel. However, it is not an issue at all to do it with some of the analytical tools which are available, like databases, IKEA. We do that in our courses. Very, very easy. So we can actually start looking at doing more complex tasks. Not exactly a requirement, it's as much as a requirement as a benefit, because once we start actually demonstrating that we can do more complex work, and we can do more complex analysis, we are starting to deliver value for the organization. So we can actually demonstrate return on investment to the audit committee, or to the chief financial officer, or to the chief audit executive, whoever the person was who actually signed off on that initiative. So now we need to start looking at more complex things. Okay, some of the components that we use, the first one is business intelligence. Again, a very broad term, but essentially a business intelligence initiative is designed to allow non-technical professionals to get access to the data and run their own reports. This is one of the main benefits of business intelligence. So we do not want somebody out there, can be the IS team, or can be the report writing team, or somebody else, to write the reports, so that we need to go and talk to them, tell them what we want, they'll do it, they'll give it back to us, then we need to go back to them to tell them that we made a mistake, or they made a mistake in delivering it to us, or we made a mistake in terms of what we wanted. No, actually, when we give the user, the end user, the business user, the opportunity to do data exploration, which essentially is what it is, they can become much more productive, and they can get the insights that they need. Because sometimes when somebody says, tell me what report do you want, quite often, and I've got so much experience, I don't know the exact answer. I need to see the data, I need to have a look once or twice at it, and only then I can actually provide a little bit more information in terms of what I want. However, if I'm allowed to do, if I have the ability to query the data and get the information out, then eventually I can provide that information, and that can be a report which goes into the system, or sometimes I don't have to. I basically got the information that I need. So business intelligence is the first one. Basically giving business users the ability to query the organizational data without having technical skills. That's the most important thing. You don't need to be a database designer in order to start using and writing some business intelligence reports. So how that is done? Usually most business intelligence systems work with the so-called data cubes, where they summarize the information across different criteria, the so-called dimensions. So here, for example, there is a very simple data cube which looks at locations, like there are 4 locations, 4 stores, Vancouver, Calgary, Toronto, and Montreal. Looks at specific customers who bought something, and looks at what parts they bought, part 1, part 2, part 5, part 5. So all of that is summarized. So actually, this cube, which contains 4 by 5 in the first yellow plane, 20 elements multiplied by 4. So this cube, which contains 80 elements, probably comes from the transactions that have occurred in the last year. So probably 100,000 transactions have been summarized into 80 different numbers. Because of that, there can be 5 business users querying this cube and getting the information instantaneously, as opposed to running it on the source data, the actual transactions, which is, as I said, a huge data. So makes it very easy and very quick for the business users. Now, the other thing, cubes allow information to be presented in a way that is much easier to understand for a business user. Like, for example, well, usually these things like store location in a database will be called some cryptic name, loc underscore 1, 2, 3, 4, 5, and it's anybody's guess where the actual location that we want is there. All these complexities of database design are hidden from the business users. So we have here store location, customer, part. Whatever they are in the database doesn't matter. So the data cubes are the ones which allow business users to query quickly the information in a way which makes sense to them. So you might have heard about business intelligence, you might have used it. If you haven't, this is the main purpose of business intelligence. Give the business user the ability to run their own reports and queries. Specifically in audit, business intelligence is one of the keystones for continuous assurance. What you see here is a graphic that is provided by the Institute of Internal Auditors, showing how the 3 lines of defense, the first line, second line, and third line of defense, which is audit, how do they fit together, and how continuous auditing and continuous assurance cross, again, all these 3. In a simple term, basically what it is. When you have business intelligence solution and you use it to run some audit tests and audit reports, you eventually move into the area of continuous auditing because you can run those reports on a regular basis. If it's a payroll report or set of payroll reports, you can run them fortnightly. If it's some other type of report, sometimes you run them quarterly, sometimes you run them monthly, for example, for accounts payable. For maintenance, probably they are monthly as well. But as an auditor, you actually have the ability to run these reports continuously, and usually there's a process sitting behind it. This is what we talked in some of our courses. So that's one thing. But the important thing about business intelligence, as I said, business intelligence allows business users to get access to information. So now when we start with continuous auditing and audit starts running the reports, eventually some of these reports can be sent to the first line of defense, to the actual business area to be run, and they become a continuous monitoring. So now, if I take the example of payroll, which exists in any organization, the payroll team can run some payroll reports on a fortnightly basis, and then the audit team may run similar reports on a quarterly basis just to see what's happening. So basically, the 2 areas are working together, the first line of defense and the third line of defense, in this case audit, and this leads to the true continuous assurance here. So if you look here, so basically at the top it says continuous assurance is achieved through the internal audit activity, audit testing of first and second lines of defense, which do continuous monitoring, and then continuous auditing, which is done by audit. So this is the model that IIA has. This is the same thing explained a little bit more simply. But underneath all that sits business intelligence. That's why business intelligence is very important when we start looking at more advanced concepts in terms of audit analytics. Now, the other thing that is linked to business intelligence, usually business intelligence tools provide data visualization capabilities, which are very important. And we want to be able to actually leverage those in order to make whatever we present to the stakeholders, can be management, can be audit committee, can be the actual middle managers in the business area, to have more credibility and so that we can also, it's easier for us to convince them. And I'll give you an example of data storytelling. Data storytelling is a very broad concept. Usually takes at least 1 or 2 hours to scratch the surface that we do in our training, but I'll give you an example here. Here's a table. This comes from a report which was commissioned, this comes from research That was done 3 or 4 years ago. It's Indonesia. It was about the Indonesian National Audit Office, BPKP. So here's a table. The first table shows some of the findings, some of the ideas behind it. So it says how many cases have been investigated, fraud, what happened, what are the involved amounts, minimum, maximum, and so on. Then the various, in second table are the different variables that we're using in the research, and number 3, some additional variables and how much the deviation is and what was their importance in terms of relevance to the final result. And basically the article eventually said BPKP, the National Audit Office, is doing a great job. Now, when you look at the 3 tables, and when you look at the conclusion, personally, when I look at that, I find it very, very difficult to be convinced that based on the information which is here in these 3 tables, which I'll get a headache just looking at it, it'll be very difficult for me to get convinced that BPKP is doing a great job. Maybe they are, maybe they are not. The research says that they are doing a great job, no question about that. But let's think, how is it better to actually present all that information in order to really convince the reader that that's the case? Okay, so now we want to put some context, to give the reader some introduction, and basically it says, okay, due to corruption, the losses in Indonesian government sector were 31.1 trillion Indonesian rupiah. Gives you the total for 2015, and it focuses your attention to the word corruption, which is a slightly different color, stronger color than the rest of it. Now, there have been 128 BPKP reports that were done in 2012-2015 period. So that gives you again a summary of the situation. They found on average 1.29 fraud cases in each provincial government in the same period, 2012-2015. Here's the minimum and the maximum of that 1.29. So some provincial governments had 0, some provincial governments had 4.5. The average audit opinion, based on the reports provided done by BPKP, is 3.87. 3 is qualified, 4 is unqualified, so pretty close to unqualified. It shows what are the irregularities, the bottom line, and the corruption that was uncovered. Gives you a link between the 2, and eventually we can say that based on what we have found, based on the average audit opinion, based on the fraud case that have been discovered, that BPKP is highly effective. And we put some context underneath, as mandated by President Law number 192 from 2014. This is exactly the same information as the previous slide, where I just showed you the 3 tables and said that BPKP is highly effective. No idea whether they are or they are not. This is exactly the same information presented in a different way, based on the information from the same 3 tables that you saw earlier, which makes a lot more sense to a human. All right? When you present that to a senior manager, to a board director, to a CEO, to anybody, people are much more likely to be convinced that BPKP is highly effective, as opposed to if they see this thing here. And it is exactly the same information presented in a completely different way. So this is the power of data storytelling. This is the link. The reason I'm bringing that here is because one of the things about business intelligence is data visualization capabilities, and we want to be able to use those in order to actually support what we are trying to present in terms of ideas. Some of these things are done manually. Some of these things are done using business intelligence. I'm personally most familiar I have used Oracle Business Intelligence a lot, and also Microsoft BI. These are the two main tools that I have used when I was managing continuous auditing implementations. I know that there is a number of options on the market out there, and various organizations are using various things. It doesn't matter. The point is that most of the BI tools have got some visualization capabilities that need to be incorporated into our audit reports, and treat the report as basically a sales piece, because when you write a report, you are trying to convince the business area, the audit committee, the senior managers that your findings would require this and this action, because otherwise you provide the recommendations and think about in your minds how many times people have accepted your recommendations without saying anything. For me personally, that would probably be less than 25%. Usually they fight, why do you say this, why do you say that? But when you present it like that, you think, okay, well, maybe there is a point. And all of this came from the journal, the information came from the Journal of Society and Governance, for those of you who are interested. Now, another part of advanced data science, the one we're moving into that, is big data. Okay, big data, there is a lot of hype about big data. Some organizations are using it well, some organizations are not using it well. When I was coming to Malaysia often, I've talked to a number of people, so the situation is very fluid, so to speak. Some organizations are quite advanced, some of them are still struggling. But what exactly is big data? Very briefly, big data is characterized by three parameters. The first one is volume. And what you see here is a prediction by Forbes how data volumes will grow. When you look at 2010, there is hardly any data. Okay, so now suddenly the volumes are growing. And by the way, this graphics was done before COVID-19, before the pandemic, the lockdowns, and the increased use of digital technology. So I'm pretty sure that now the situation is even, the amounts are even higher. But we're dealing with a lot of data, which is growing constantly, simply because we're using more systems. The transaction number, the transaction volumes through the systems that we have are increasing. We're looking at different data sources. So this is what requires some specific solutions, and this is where big data fits in, because you cannot process some of these things here using the normal solutions like databases or anything like that. The second thing is the velocity. We generate data, a lot of it, and we generate it very quickly. So here is a statistics from 2019 where you can see what we are doing every minute of the day. Every minute of the day, Netflix users at the top, which is the yellow sector, close to 700,000 hours of video. Giphy serves 4.8 million GIFs. The hashtag love is posted 23,000 times. Instagram users post 277,000 stories. Uber users at the bottom, or in case of Malaysia, that would be Grab. Also, in case of Southeast Asia, Uber users take 9.7 rides per minute. So this is the type of stuff that we have to deal with, and in the context of fraud, I can give you an example. Think about it. Think about this: you are standing in front of an ATM in New York and you withdraw $200. All right. 2 hours later, somebody using your card withdraws $300 from an ATM in London. You cannot get from New York to London in 2 hours. Yeah. Teleportation still does not exist. So this is clearly a case of fraud. So we have a lot of transactions going through the international ATM system because all of the ATMs are connected. Okay, we have a lot of transactions, and in that huge amount of transactions, we need to be able to very quickly find and analyze the cases of fraud like that. These are not just single cases. Usually there's quite a few of them. So the systems need to be able to cope with the velocity of increasing data, as well as the velocity of analyzing the data quickly in order to do something with that data. Whether that's fraud, as I said, ATMs, one in New York, one in London, or if it's a user on a website who is just about to leave, but if you keep them, if you offer them something, if you put a pop-up there saying, do you want to do this, or do you want 10% discount or whatever, you may actually keep them on your website and complete the sale. This is all linked to the velocity and to big data. Which brings us to the next one when you look at these graphics here, which is the variety. We're dealing with a lot of different data. When I started my career back in '94, the only data was the structured data. Everything was sitting in databases. That's not the case anymore. So now we have structured data, we have semi-structured data, which is coming from IoT, Internet of Things, all these little devices which are currently being connected online, little sensors, temperature sensors, pressure sensors, other things, little cameras that we all have at home and organizations have in their premises. That's all semi-structured data. And then we have the unstructured data, which is everything else, basically all of the stuff that comes from YouTube, from any of these sources here, because these are neither structured nor semi-structured. They are in whatever format you can think of. So all of these things we need to be able to analyze. That poses some unique challenges. Having said that, we can analyze. We now have the tools to analyze them, and I'll show you a demo in a few minutes. One such tool and system that I have developed. Now, from an audit perspective, one of the most important data that hardly any audit teams analyze sits within the corporate emails and in PDF and Word files. Okay. Now, when we analyze data from a system, I'll give you an example. When we analyze data from the project management system, which provides some dashboards with green, yellow, and amber lights showing the status of each project, and there's a project A, which has got a green light, so everything's great. While at the same time, the emails between the people working on that project go along the lines, this project is a complete wreck. I better leave it because I don't want it to impact on my career. Another one, I cannot work with these people because I don't know what they're doing. And when you see that type of negativity in the emails and the project light is green, which one would you believe? If I had the opportunity to analyze the emails, I would believe the emails, because this is where the real situation sits, not in the system, which shows that everything's sweet. And then, of course, the project just goes off the rails, over budget, or get canceled, and the blame starts. But as auditors, there is the opportunity. These are the things that we can do, actually, using big data. Now, coming from big data, next one is artificial intelligence, where, again, we can start doing things that we haven't done before. By the way, AI sounds really scary. It is not. Some simple forms of AI we teach in our courses, where actually we can get people to start using AI in a meaningful way in their work for evaluating project management risk. But what exactly is AI? It is, according to Forbes, it is thought of stimulating the capacity for abstract, creative, and deductive thought, and particularly the ability to learn. So we want to be able to get the systems to have a look what happened in the past and to actually learn from that and tell us what potentially may happen in the future and what are some of the factors that caused the problems in the past, so that we can write them in our audit report and say, based on that, we recommend that you do this, and this to fix process X and process Y. Going to the example, back to the example for project management, most large organizations have got some sort of a register with information about the projects that they have run in the past. Using that information, it's possible to train a system to learn what are some of the problems that the projects experienced in the past, particularly the projects that were failures, failure defined as whatever the definition is, but let's say anything covered 30, anything that was discontinued or went 30% over budget probably is a failure. What caused this failure? And it's actually quite easy then to get some new insights when you train a system to learn from the past. Well, maybe some project managers cannot run big projects. Maybe project manager A was performing really well when he was running projects that were between 10 and 25 million ringgit, and then he or she started failing abysmally when they got them to run projects between 50 and 60 million ringgit. Well, if that's the case, let them run whatever they could and put the ones that can run bigger projects to do them. All of these things actually we can learn from past failures and we can incorporate them in our audit report. This is what partially AI is. There are, again, a lot of terms and words being thrown around, but here is how some of these fit together. So artificial intelligence is the broader concept. Machine learning is a subset of artificial intelligence, probably the most widely used one at the moment, and the one that is relatively easy to be taught. Deep learning is still a very low percentage. It is very powerful, but deep learning is left for, at this stage, probably for companies like Tesla, Google, or Facebook, which have got the data and which have got also the skills inside the company in order to do that. But for most of us, probably machine learning, which is, again, type of AI, is the one that we can use. One other thing I would like to mention before I move onto the demo is big data and AI are linked very strongly. And one of the reasons AI now is becoming more and more powerful is because we have the capacity to process larger amounts of data or big data. So big data, well, data is the food for AI, and big data is the food on steroids for AI, basically. So the more data you throw at AI, the better it will become, because it will keep learning and adjusting. That's why these two should usually go hand in hand, and it's important to keep that link in perspective. So now we have a few more minutes before we conclude. I can see that there's a few questions here. If I don't have the time to answer them now, I'll write something in an email. So I'll just go to the demo now. So here's a system which is created in KNIME. KNIME is a tool for visual data science. So when you are using KNIME, you don't need to know how to code. If you don't like coding, you don't have to write a single line of code. KNIME is also free, and this is the reason that we are using it in our data analytics and data science courses that we run because there is no issue with licensing. NIME has got an open source license that allows anybody, any enterprise to use NIME. So this definitely helps because usually in an audit team there would be 2, 3, 5 ACL or IDEA licenses, and when 20 people come to training, not all of them can work. The other thing is that if everybody is using NIME, that means that actually they'll become more productive. Remember, I mentioned earlier that I personally think that 80% of the people should do some simple data analytics. Now, this is not simple, this is complex, but here, this is a system which is designed, this was part of my PhD, this is part of my PhD research. This is a system which is designed to detect synthetic identity fraud in online credit applications. Okay, synthetic identity is when the person doesn't exist. Somebody takes my name and somebody else's driver's license and the fake address, combines them together and create the identity. It is one of the types of financial crimes which are on the rise at the moment for a number of reasons without going into too much detail, but these are synthetic identity is becoming a bigger and bigger problem for various organizations. All these little pictures here, squares that you see, do some work. They are like little pieces of software, and the gray squares that you see here are like bigger pieces of software. Each one of these is actually the so-called meta node. The little squares are called nodes. This one is called meta node, and it contains a series of other nodes. Okay, so now what this system does here, it processes data from Twitter, the orange squares from Facebook, the yellow squares, and also it analyzes answers of a credit applicant. So this is the so-called NLP, natural language processing, which is a type of artificial intelligence. Based on that, then it provides an output to a system or an output to a human to see whether a specific credit application is fraudulent or not. So I will just run all of these together. So here we'll just run the analytics and let's see what the system will do. So now it's reading data and it's performing various types of analysis. There are 5 things that the system analyzed based on the output data. Looking at my own data from Facebook and Twitter. So it looked and considered the premise of the system is that people can create synthetic identity relatively easily, but it's very difficult to create the footprint associated with a synthetic identity. So I can create an account on Facebook today and put 55,000 posts there, but all of them will be time-stamped today. So I cannot actually create a post on Facebook today that is 2 years old. So in this case, there's something wrong if there's an identity, but there's hardly any length of activity or any number of friends. Yes, I know that there are people who don't use social media, so these are different considerations, but just to give you the main things. So this performed 5 different types of analytics, and it looked and said that the Facebook activity is okay. The Facebook number of friends is okay too. The answer that I've given to a question on the credit application, what I'm going to be using the funds for, is suspicious. My Twitter activity is suspicious. My Twitter followers are okay, so there's 2 out of 5 which are suspicious, and that can be then flagged and sent for review by a human officer. So this is here what you see is big data, unstructured, because we are pulling data from Twitter and Facebook, together with AI, natural language processing, looking at the topic answers to identify some suspicious trends or not. You can see here in visual form what the system produces. So here it is. This is my own Facebook activity here at the top left corner. Looks quite okay. Initially 2014, 2013, 2011, I wasn't doing much. That's why the nodes are red, the circles are red, but after that it was okay. My number of Facebook friends, again, 2010, 11, 2012, not good, but after that I do have the normal number of friends. My Twitter activity, this is a simulated account. I haven't done absolutely anything on Twitter except put a few tweets in 2020. This is not my real one. So that looks suspicious. That's why the system flagged it like that. And my Twitter friends, they seem to be okay. When I started with Twitter in 2007, I had only a few, but after that, I have the normal ones. So I just wanted to show you, talking about advanced data science, I just wanted to show you what are some of the things that can be done. Of course, nobody is saying that we'll start with that. We just need to start slowly. But this is where we can end eventually when we start incorporating data science more and more into our activities. So this is the end of the session. I'll just have a look at some of the questions. I don't think that I'll have the time to answer all of them, but just quickly. So this is the same definition as data analytics. Again, the opinions are very different. Personally, I think that it is more than data analytics. Data analytics is simpler, although you can make it as complex as possible. Personally, I think that data science is more complex because it looks at things outside the pure data analytics. It looks at artificial intelligence. It looks at big data. It looks at pre-processing and amalgamating data, data cleansing. So all of these things, some people do them as part of data analytics. Some people don't do it. Quite often, data analytics is seen as getting a data set which is already relatively clean and running it through a tool like IDEA or ACL or Excel. So personally, I think that the data science is more encompassing. I'm not saying that it's much more difficult, but it's simply bigger than that. Okay, where can I know where I can start to learn data analysis, data scientist? My background is in accounting and finance. All right, so difficult to answer this one. If you're really interested, my suggestion would be to go and have a look at some of the free courses on Udemy and some of the free videos on YouTube. This is a good starting point. Eventually, you're going to outgrow it, but just to give you an idea where we are, I think this is a pretty good starting point. Just, the next question. Just here. So the next question, what does it take to do data science? Is it like doing VLOOKUPs or any Excel function to understand the controls in place or to get the right sample? Okay, so no, it's not. It's a lot more than that. These are just some of the basics of data science. Now, talking about samples, I'm not a big fan of samples. I say that at every course when I run something. I don't like sampling. I like analyzing the whole population. In some cases, it's okay to analyze samples if there is no other option, and sometimes it's okay to sample the exceptions. Okay, but when you have a big data set and you know the exceptions are 0.5% or something like that, because most records are okay, most transactions are not fraudulent, most people are normal customers, not synthetic identities. So when you're looking at that, sampling is not good. But if you know that these are all of the exceptions, it's okay to sample them because the data set actually represents the same thing. So, but it is more, as I said, personally, look at some of the videos and some of the free courses. Now, as a starting point, that's good. In terms of data science, download KNIME. I'll write it down here. KNIME is spelled K-N-I-M-E. It is, as I said, a tool for codeless data science. So you don't need to be a technical person. You can start with KNIME and you can do some basic data science and then progress from there. But as I said, online training is okay. Videos are okay. There's a number of books. I cannot recommend anything off the top of my head, but if you do a search on simple data science or introduction to data science, you'll be able to get a few. Now, is there any data model that is helpful and which is commonly used in Australia for auditors? Personally, the data model depends on the area that you're analyzing. So there's a data model for payroll, there are data models for procurement, there are data models for each one of those. Please feel free to send me an email. I can share something a little bit more specific if I know what you're looking for. The next question. I'm interested in data work. Can I learn an application such as Python, SAS, Tableau, machine learning, deep learning? I am from another background. My background is in accounting and finance. I would like to mention, excuse me, I would like to mention something here in terms of the effort which is required. My suggestion would be, if you're not coming from a technical background, or even if you are coming from a technical background like myself, do not try to learn Python, SQL, and things like that. All right, I've spent over 15 years writing SQL. It's a great tool. For an auditor or for a business professional, you don't need to go that deep. Just use some of the tools which are available. Use ACL, use IDEA, use Excel, use KNIME. So don't try to get down into the actual programming languages, because unless you want to make a career as a programmer, personally, I think it's counterproductive. You want to be able to get a business outcome. You want to be able to run a simple audit test and get the results. To do that in Python, it will take forever. SQL is a little bit better, but to run something simple in Python, you really need to spend the time learning it. Of course, if you're interested by any means, but my advice would be don't do it. Are there any tools to extract data in email communications? Yes. Well, actually, you can ask one of your system administrators. This is what I have done in the past. I will ask the IT infrastructure people, the sysadmin, or whoever is responsible for the email system, to actually give you the data from the emails. Not the whole data. They can extract the metadata separately, like sender, receiver, subject, and so on. And they can also extract the text of the emails. So maybe there are tools, but the problem with the tools is that you need to get the permission to put the tool in the organization and to run it. So it's much easier actually to go and speak to the system administrators, and they'll give you the data that you need. Okay, so these are the main questions. This is the end of the session. Thank you very much for being here. For those of you who are in Malaysia, I would like to mention that MBS Academy is an Australian company. However, we do have a Malaysian subsidiary, MBS Academy Malaysia, which is registered with HRD Corp. All of our courses, specifically the one data science in Audit, Days, Foundations, and Advanced, all of our courses are HRD Corp claimable. They have been submitted and they are approved. So if you are interested in coming to the training and speaking with some of your colleagues, actually you can get to the training for free if your organization is contributing to HRD Corp, because you can just use the credits for that. So on that note, also you will receive a link with the presentation and with the recording of the session shortly. I will send it to all of the people who attended today's session. It was great to be here. Please feel free to contact me on my personal email as well. I'll just write it down here in the chat box. Here it is. Feel free to send me an email. If not, I look forward to seeing you some of the other sessions that are coming. A couple of weeks ago, we ran Auditing Digital Risk. We're going to run it again in the next few weeks. We'll also run the Foundations of Data Science shortly. So register with our LinkedIn page. Our main form of communication is LinkedIn. So when you go to LinkedIn, the first address is the one, MBS Academy. Register to our page. We publish all of the information there. That's it from me. Have a great afternoon and see you soon. Bye now.